pseudostratified ciliated, because we have to have hairs in there, so we can brush things up and out. So the outer edge, the cartilage, is one kind of connective tissue, and then the inside is that epithelial tissue with the hair. So we can, when toxins come in or irritants come in, we can cough them up and out, and those cilia brushes them up and out. So the inside is lined with cilia, the outside is out here for structure. So it keeps the airway open, that's the cartilage part. The cilia inside is what helps also protect by brushing things out. So two different kinds, we'll look at that in lab when we do that. So we'll see the cartilage on the outside and the cilia on the inside. So all larynx stuff up here. And then here's our vocal cords, that little slit there. The top one is called the false or vestibular fold, false vocal cords. And the bottom one is called the true vocal cords. We'll look at that in lab as well. False on top, true on bottom. And then there's a slit in between, that opening in between the vocal cords. This part right here is called the glottis, and that's where the sound goes through and vibrates across those vocal cords. So the slit is the glottis, and that makes this part the epiglottis. That's the flap that goes back and closes down the esophagus. So this is our epiglottis right here. That's what we're looking at. This is all the larynx stuff. And this is going to come back and close off the esophagus so we don't get, or it's going to close off the airways so food and liquids don't come down. So that's our epiglottis. And then that opening is the glottis. That's why it's called epi, because it's above the glottis.
There are tongues connecting to the epiglottis or the hyoid?
It's connecting to the base of the hyoid, and then we have kind of like this cartilage connection back here.
Okay.
So the opening glottis, above it is the flap that protects the airway, that's the epiglottis. And that's this big flap here. When we look at the model, this big flap is on the back, and that's the epiglottis, so you can see it opening and closing. So it's, when we can see it in lab, it'll make a little more sense. And then that's the that's this part right here, is this part right here. So larynx up on top, hyoid, thyroid, cricoid, that's all part of the larynx. Inside we have the vocal cords, false on top, true on bottom. And then we get into the individual rings. Those are the tracheal rings. All of that is made up of cartilage. So here's our voice production. Pitch has to do with the thickness or the tightness of cords. Girls have thinner, more tense vocal cords. So air comes across, it's going to vibrate higher and a faster pitch, so we're going to have that faster pitched voice. And girls have softer voices sometimes. And then boys have thicker cords, so it's going to be a slower vibration, and they're going to have a lower tone in their voice. Loudness depends on how forcefully you're pushing air across that opening. So if you're yelling, you're forcing the air across that, so it makes your voice louder. So when you're whispering, you're barely vibrating those cords, so you don't hear much. If you're yelling, you're like, they're really getting in there and aggravating those. So the loudness has to do with our larynx as well. And we've all probably felt that at some point where you overuse your voice for whatever reason, or you have laryngitis, and it just hurts to put sound across there. So you, even if it's not making the right sound, you whisper because it hurts to vibrate that. So that loudness and higher low pitches has to do with your vocal cords and the thickness of them and how air is moving across them. So that's pretty cool. All right, down into the lungs. So we're moving down, the trachea is coming down. Trachea is what we call our windpipe, that's where air is coming down. And we have the cilia inside there, so we can brush things up and out. So it goes from the larynx down to the trachea, that's what we call our windpipe. And below the trachea are the bronchioles. And smoking, if we get whatever the toxin is, but nicotine and all the stuff that's in it, as it comes down, it paralyzes that cilia in there, so that's why smokers have that cough, is because they don't have that cilia helping push things up and out. And it could be, you can work in a factory, and it could be the stuff you're spraying, whatever the irritant is that gets in your throat can paralyze those cilia in there. If you get out of that environment or you stop smoking, then they'll regenerate and they'll come back. So the trachea has the cilia. Then we're going to branch off. So we have our trachea, and then we're going to branch off. Let's blow that up. Where it splits, this is just like the common carotid splitting the external and internals. Same thing, we have our trachea coming down and it's going to split. And when it splits, we call them the bronchi. And we have a right and we have a left. And then it's just going to keep branching and branching and branching, just like a tree. So the first part are called the bronchi, or the primary bronchi. Put that down in a minute. The further we get away, we're secondary bronchi. And we get further away, we have tertiary bronchi, and then we just have terminal bronchi. So we don't have gas exchange until we get into the lungs. We have to get out into these bronchioles. Otherwise, we're just moving air in and out. That's the conducting zone. Once we cross into the bronchioles, then we're in the respiratory zone. We're actually moving oxygen and carbon dioxide. So we have primary where it splits, that's a right and left primary. We branch off, these bigger branches are secondary. And then we start getting into those small branches, those are tertiary. The three with the circle is tertiary. So primary, secondary, tertiary. And by the time we're done, those bronchi are going to divide 23 times. So we're just getting smaller and smaller and smaller. And what happens is we go from cartilage, a pretty solid structure, so that we can keep that airway open, to further and further away, we get into less cartilage and more smooth muscle. And that's why out in the furthest parts of the lungs, then we're having gas exchange out there across that tissue. Cartilage, going less and less cartilage, moving into smooth muscle. Primaries, and then if we branch off, secondaries, the further we get tertiaries, and then eventually these teeny tiny little ones are going to be called terminal bronchioles, and that's where we're doing gas exchange. A couple more slides, then we'll be done. So here we are, we're branching, we're branching, we're branching. Primary is branching off, secondary is still blue, and then tertiary are these tannish colors, and that's our terminal bronchioles when we get to the end. And then at the end of those, we have this whole little great cluster thing going on. And that's where gas exchange actually occurs. And that's called the alveoli. So we're branching, branching, branching 23 times. And at the end of those branches, we call them the terminal branches, we have these little grapes. So an alveoli is like a cluster of grapes. The alveolar sac is a cluster of grapes. And then each individual grape on there does gas exchange. So we have the cluster, and then we have the individual alveoli. Each individual grape is an alveoli. And they are very richly surrounded with capillary beds, and that's where oxygen and carbon dioxide get exchanged through that bed. Now we're into the respiratory zone. So here we are, this whole cluster is our alveolar sac. And then the individual little grapes, those are the alveoli. And each one is covered with capillaries. So we have a really vascular bed in there. And we're going to get oxygen out of the lungs, up and out to the rest of the body. And we're going to get, we're going to deliver it all through the body. And we're going to get carbon dioxide up and out and get rid of it. So this is where that gas exchange happens down at this level. So if we look at each individual alveoli, that's what we're seeing. We're inside the lung. We want to get oxygen out to the blood and deliver it to all the tissues. And in the blood, we want to get rid of carbon dioxide, the waste product. We're going to put it in the lungs. We're going to come up the bronchioles and up and out and down. So this is where gas exchange happens, is right there on that capillary bed. So blood is flowing through those capillaries. It's going to dump carbon dioxide into the lungs and say, get rid of this. And we're going to pick oxygen up from the lungs and dump it into the blood and say, you go deliver this to the rest of the body. So that's where gas exchange occurs, down in this little part here. Oxygen from the alveoli goes out to the blood and the rest of the body. Carbon dioxide from the body and the blood gets dumped into the lungs, and we breathe that out. And it looks like that on this picture. So that's showing how gas exchange is, this is across that capillary bed that's going around each individual alveoli. And then we have our type 2 cells in here, the little green things, those make surfactant. Remember when we talked about overcoming surface tension in chapter 3? Is when we're breathing and respiration, we're putting off moisture. And so what the lungs want to do is they want to close. Those hydrogen bonds form surface tension, and they want to close those lungs. And we can't have that, because every time we breathe in, we have to breathe out. And if surface tension had its way, it would slam those lungs shut every time because of hydrogen bonds. And the body says, well, we can't have that because we have to go every time we had to breathe out. When we breathe in, we have to do that. We'd be exhausted if we had to breathe like that. So these little type 2 cells living inside the alveoli produce that chemical called surfactant, and it lines each individual alveoli, and it's like egg whites. It's a slippery substance. So when we breathe in and we breathe out, the lungs can't slam shut and they slide across each other. So that helps with decreasing surface tension. Surfactant will allow us to slam those and have those hydrogen bonds hold it shut. And this is what happens in preemies. This doesn't come on board until 7 months in utero. The ability to make surfactant is not there until the fetus is 7 months old. So you're always trying to get another day, another day, another day. The closer you can get to 7 months, the better the baby's going to do with their own ventilation. So if they're really early, we have preemies born all the time now, 5 months and stuff, and we can fix that. We can give them an injection, but it's never going to be as good as the man-made stuff. And we can put them on ventilators and stuff and gently expand it and take care of their lungs for them. So that's why we're always trying to get to that 7th month. Once they hit that, pretty much everything is developed. 2 more months in the oven would be better, but if you can get to 7 months, that's your ultimate goal, is to try to get that far. And that's because of surviving. So there's the lung. We have right and left sides. The right has our 3 lobes, superior, middle, and inferior, and the left has superior and middle, or superior and inferior. All right. So that's our basic anatomy. That's slide 13. So we're done. Go have a good weekend. If you're done, you don't have